Okay. Good afternoon, everyone. So, welcome to our discussion on analysis of external reactions and internal stress resultants of statically determinate structure, specifically plane and space stresses. So, before we start, um, Happy New Year, everyone. So, this may be a bit too late now. So, we are very sorry for the delay on your discussions. So, actually, we are on module 2 pa lang. So, if mapapansin nyo, we are quite naghahabol ng oras. So, medyo paspasay kita. So, please bear with us for these discussions. Okay? So, for this discussion, it's actually divided into 3 parts. So, we'll start with the stability and determinacy of truss, then analysis of truss, specifically stress analysis of truss, then the analysis of roof truss. Okay? So, actually, space truss is the 3D trusses. However, we decided to discuss roof truss instead. Okay? Okay, so let's start with, so from the title itself, we are only dealing with the external reactions and internal stress resultants of statically determinate structures. So again, specifically, statically determinate structures. So we are not dealing in this lecture the indeterminate structures. So how do we find if a structure is statically determinate or indeterminate? And that will be our next lecture. Okay, so let's start with the stability and determinacy of structure, specifically the plane trusses. So to find if our truss is determinate or indeterminate, we have to use the following formula. So for those who would like to know if how this formula were derived, nakikita. Okay na? Okay, so ito. So much clearer na siya. So if you would like to know if how are these formulas were derived, so please visit AF Math and Engineering at youtube.com. So dun mas specific an discussion on how were these formulas derived. So our M plus R, if our M plus R is less than 2J, that is our structure is statically unstable. If M plus R is equal to 2J, our structure is statically determinate. So in this lecture, we are only dealing with this type of structure, diba? The M plus R is equal to 2J. So dapat equal sila. Then M plus R is greater than 2J, that is structure is statically indeterminate. Our R are the number of support reactions, R for reactions, J for the number of joints or J for joints, M for the number of members or M for members. Okay? So, let's try to solve. Let's try to find if a structure is determinate or not. Okay? So, we have this example. So, let's try to move. Tama ba? Yun. Okay. Sorry. Okay, so transfer. So let's try to solve first. Teka lang. Where is it? Okay, so let this be the figure for our first example. Okay, given a truss, of course, truss lang naman yung pinag-usapan natin dito. So, yun. So, given a truss, how can we know if this is determinate or indeterminate? So, again, we have to use the formula M plus R we will find pa kung equal, less than, or greater than 2J. Diba? So, in this trust, our members, as how many members do we have? So, we'll just count the number of members of the trust. So, for this member, this is not continuous kasi may pin siya sa gitna. That is a member between. So, that is counted as 2 members, di ba? So, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13. Then, so how many reactions do we have? So, for our roller, we have 1 reaction, then 1 reaction. For a hinge, we have 2 reactions. So, how many reactions? That is 1, 2, 3, and 4. Then, for the joint, so anything na mayroong members na nagko-connect is a joint. So, we have 1, 2, 3, 4, 5, 6, 7, 8 joints. So, our J is 8. Okay. So, let us use the formula M plus R, that is less than, greater than, or equal to 2J. So, M is 13. Tama ba na akong joints? Tama. So, 13 plus 4. And 2J is 2 times 8. Okay. So, 13 plus 4 is 17. And 2 times 8 is 16. So, therefore, that is greater. So, our M plus R is greater than 2J. So, this is indeterminate. So, in indeterminate structures, we have to have a degree. Diba? Parang pagbasa is dapat may nakita like to the nth degree, di ba? Parang ganon. So for this structure, so how to find the degree? So that is just minus lang naton ang aton M plus R. By the way, our M plus R are the yun. So bali pa plus lang naton M plus R, bali that is M plus R minus 2J. So that is our number of degree. So that is 17 minus 16 is equals to 1. So our structure is indeterminate to the first degree. So this is true to all indeterminate structure. So komperaan sobrahan M plus R compared to 2J is the degree han aton structure. Okay? So some authors use the formula R is equals U minus E. We use the number of unknown and this the equation. So R is the degree of indeterminacy or the redundant. Okay. So let's move on to the next sample. Tatlo lang ang example. Pero ako nakaka-add. Nakaka-add yung picture. So, hindi rin na drag.
Hindi, copy-paste.
Copy-paste. Ayun. Yung arte niya. Drag and go on my log to before.
Liwat din.
Hmm? Ayun na ito. Hindi mo kinikita. Hindi naman natin kinikita. Okay. So, klaro ba? Okay, so we have another example of our truss. So, this is again a simply supported truss. So, this is a ruler. Medyo blurred, no? Then, this is a hinge. So, we are to find the stability and determinacy of the truss. So, again, we'll be using the formula M plus R equal na lang to J. Okay. So again, how many members do we have? For this truss, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Tama? That's 10. How many reactions? This have 1 reaction for ruler and 2 reaction for hinge. So all in all, we have 3. Then how many number of joints? 1, 2, 3, 4, 5, 6, 7. That is 7. So this is 13, 14. So that is not equal, but 13 is less than 14. So this is unstable. So imagine a load subjected at this point. So what do you think will happen to the truss? So malamang sa malamang magkukulapse siya. Alright? Okay. So let's move on to the next. Next problem. So this is our last example for the determinacy of truss. Okay, so we have this truss. By the way, can we call this structure a truss? So by definition, a truss is a structure composed of series of triangles. So this structure being composed of series of triangle is a truss. So bakit dire yan naka-triangle as a whole, dire karag signon nga dire hiya truss. Okay, so again, using the formula M plus R greater than, equal, or less than 2J. So how many members do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Tama ba? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Plus reaction. So this is a hinge 2. This is a ruler 1. So that is 1, 2, 3. Then 2, number of joints is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. By the way, paano ko nasabi na ang ruler is just composed of 1 reaction and the hinge is 2? You please go back to my discussion on equilibrium ba to, Sir Mark, no? Discussions on reactions pala. Okay? So, that was discussed on our previous topic. So, this is 7 plus 3 is 20. 2 times 10 is 20. So, this is equal. So, pag equal, that means our structure is determinate. So, meaning, we can get every stresses in each member of this truss. So, kaya naton makuha tanan using only the static equilibrium equations, the summation of Fy is equals to 0, summation of Fx equals to 0, and the summation of moment is equals to 0. Claro. So, but this discussion will only be dealing with this type of truss. So, meaning, M plus R is equals to 2J. That's it. So, pag makakita ka mo in problem nga determinate and aton ihataga iyo, so that will be a big problem for you. Diba? So, yakan na ka mga daan, ma'am, determinate. So, dire kami pwede mag-analyze given only the static equilibrium equations. Okay? So, that's it for our determinate stability and determinacy of truss. So, let's proceed now to the analysis of truss. Okay. So, analysis of trusses. This is actually called stresses or the stresses in trusses. So, you may have some ideas on how this would go, diba? Analysis of trusses discussed on your CE 214 or the statics of rigid bodies. Tama? So, that is chapter 4, if I am not mistaken. So, in your analysis of trusses, you have discussed, I suppose, the two methods of joints and methods of sections. So, before we start with this one, let me just inform you some facts about truss. Okay, firstly, a truss is a structure composed of individual members, as I said before, joined together to form a series of triangles. So why triangle? I think so. Triangle is actually the sturdiest, the most stable shape for for structure. Okay. So that is why our truss is composed of triangles. Then, the joints are usually assumed to act as frictionless hinges or pins, but they are often riveted or otherwise connected to that some end restraint is developed. Generally, all the loads in a truss act or are assumed to act only at the joints. So thus, it follows that all members of a truss are assumed to be two force members which are subjected only to direct axial stress that is either tension or compression. And a truss is completely analyzed when the direct actual stresses, kind and amount, and all members have been determined. So in analysis of trusses, we are to find the stresses in each member. Okay? So we have to find if it is tension or compression kada usa nga member. So matatapos na natin pag-analyze if matapos na natin pag-find and stress kada usa nga member. Klaro? Klaro. Bakit may ka-istorya? Wala bang comments dyan? Pwede? Pwede. Oh my God. Bagin makaturog nagyap ka mo yun eh. OMG. Labi na ba naman kay analysis of trusses magsusolve kita kada usa nga member. Kaya pa? Mahagkot pa naman. Wala kasi kita para wala ano ba? Wala kasi kita pa-load. Mas maresyon ta may pa-load. Wow, mag-sponsor yung Ma'am Rina sa Friday daw, guys. Ay, bangin bukas ka dati, Rina. Okay. so yun. So, abang-abang na lang sa mga paraffol. Frames? Okay. So, yun na yun. So, So, basta, abang-abang na lang sa paraffol. So, for now, tiis-tiis lang muna. Kay wari pa kita na pa-load. Nagtitirok pa kayo. Nagtitirok para ma-answer. Okay. So, analysis of trusses, we have two methods. Actually, we have 4. So, due to time constraint, I decided to just explain the 2 methods, joints and sections. And for you also, no, dire ka masyado bombarded kadamo-damo nga information in just isang bagsakang discussion. Good luck. Okay, so yun na yun. So, in analysis of trusses, so pag concurrent daw, you are to find 2 unknowns. So, unforces, pag naka-concurrent daw, unforces ha truss, pag unforces naka-concurrent, mapili mabilangan na unknowns is 2. However, pag non-concurrent, mapili mabilangan nga unknowns is 2. Why is that so? So, ang hirap naman ito. Okay. So, anyakan, pag concurrent mo members, pag concurrent, sa meaning they lies on one point. They intersect at one point. So, so that is concurrent. So, pag concurrent mo members, pwede ka makabilinghin duha ka unknown. So, that is, if this is member, sigunta nala AB, and this is member AC. So, we can find, then, ini kayo nakakaan man na pwede here. Paano ba? Pag this is like that. So, parang ganon. So, you can only find 2 unknowns in this situation. So, the only equation you can use is the 2 static equilibrium equation, which is summation of f of x is equals to 0 and summation of f of y is equals to 0. Kuha? Kasi, dire man kamo pwede mag-moment, kay wari man niya distance. Okay? However, okay na? Na-delay. However, pag non-concurrent, so meaning may the distance, and yung pwede na magamit is the 3 equilibrium equations, that is including the moment. Okay, so are you not familiar with this? So pag concurrent, actually, that is the method, oh my gosh. That is the method of joints. Anong nangyayari? Nawawala yan ngayon ink gihapon nilin. Then, pag non-concurrent, that is the method of section. Okay, so let's try to find... Wala, sorry. Nawala yan. Naipidlit ko kasi adan ko. Okay. Asa na siya? So, ayun. So, we are bound to do the next example. So, let us have an example. What kind of truss is this one? So, later on, we'll have to discuss the different types of common trusses. So, let's try to have an example using method of joint. So, actually, we'll be using two figures. Then, we'll have to use the different methods on finding the stresses in these trusses. And by the way, this methods, the joint and section method is an algebraic method. Kasi, nagsasolve kita. We'll be using algebra in finding the stresses. So, we also have actually graphic methods, pero medyo madugo. Kaya you have to draw that one, and dapat ito naka-size, naka-dimension talaga ya. Anong term? Naka-scale, drawn to scale. Ano ba yan? Nagdo-drawing ako pero nakalimutan ang term. That is naka-drawn to scale basta graphic. So, kailangan dako talaga nga table ang kinahanglan. So, if you have known na pag theory, kailangan dakon papel na kailangan, yes, that was true. Kasi, meda talaga times nga damo-damoan talaga ang solution. Especially kung you are to analyze a whole structure. So, today, we are just going to analyze the truss. Imagine, truss pa lang to. Okay. So, let's move on to our example. Truss. So, this is some sort of review based from your CE 214. So, i-detail ko na lang din kung how to do the analysis and trusses para kahit pa paano ma-review kayo ng buwang-buwang. Okay. So, we have this structure. Kita ba? Okay, so if you want to have some practice exercises, this is available in the book of Wang and Eckel, Elementary Theory of Structures. So for those who have, you can practice. However, in Wang and Eckel, they're using English units. So pounds, ano gamit, pounds and foot. But gin-translate ko lang into our SI units. Okay, so mapapansin niyo that this is in kilonewton and meters. Okay. So are you ready? Am I ready? Okay. So in analysis of trusses, what I do first is to find the angle between the by the way, in analysis of joints and method of joints, we are to analyze from our left side to the center, then right back to the center. Para at the end of the analysis, makag-cross-check ka mo using these members. Okay? So, So, what I do first, personally, pag ako taga-analyze ng truss, ay ginuuna ko ang mga angle. Diba? So, look at the truss as a big picture. And iya talaga pinaka-shape. So, usually, this very important, labi na kung angle person ka. If we, di ba, we'll be dealing with sine. We'll be dealing with sine, cosine, di ba? For the forces. For the forces, di ba? So, that is very common, di ba? When we are dealing with forces, di ba? Usually, ito talaga yung resolve into Fy, Fx. So, that is, in resolving Fy and Fx, we usually use sine theta, cosine theta. That is, if angle person ka. When we say angle person, you are really using the theta. So, this is theta, di ba? Pag angle person ka, when you are going to find Fy, ano mo ginagamit is F sine theta. Then, ano mo Fx is F cosine theta. However, kung trigo geek ka, nga ano mo mas prefer is using the length, using the hypotenuse. So, instead of sine theta, you are using F. That is, sine is adjacent over hypotenuse. Diba? Then, pag Fx, that is, oh no, that is directly adjacent. This is opposite. So, katawa, diba? Then, adjacent over hypotenuse pag cosine. Diba? So, that is if, oh, yan. Diba? Diba, going back on our topics, actually, pinaka main solution in finding our Fx and Fy. So, ako actually is angle person ako. However, medyo makote kasi pag store. So, I prefer right now, so mas prefer ko na andin kukuha na line and length han AC. Diba? Or the hypotenuse. So, in this case, AC is our hypotenuse. So, let's find first the value of AC. Or that is the length of AC. Length of AC is simple as square root of 3.6 meter by square root of 3.6 squared plus, nako, sulat na lang natin. That is 3.6 squared plus 2.7 squared. Actually, this is case-to-case basis. That is 3.6 squared plus 2.7 squared. 4.5. 4.5 meters. So, let's just see kung hainan mas less numbers, diba? So, unlike if we're using angle, so angle, direkta ko na ha, arctangent. So, just review your trigonometry. That is opposite 3.6 over 2.7. That's 53.13. Pero damo pa itong 0, 1, so on and so forth. So, what I do is I store it in alpha A. Usually, pag angle, usually alpha A dayon ito. However, for our discussion, I'll be using the hypotenuse. Okay? Kasi parang mas less numbers and hypotenuse. That is 4.5 lang compared han imo angle. That is 53.13. Diba? Ako, hubiya man ako, mas unahon ko ito nga, guti ay laan number. Okay? So, let's proceed with our joint A. Ano pa batat kinahanglan? We need first the reactions. So what do you think of how many reactions do we have or do we need to find? So by instinct, we are to find 3 reactions. Tama ka, di ba? Hinge ini, duha ini. It opposes 2 forces. Di ba? Aniya kaya ma-react. Aniya kaya makaptan na force is horizontal and vertical. Then ang aton ruler naman is vertical lang. So we have supposedly 3. However, an aton in the external forces lang niya, looking at the external forces, the only force applied in this truss is a vertical force. So, an aton laying reaction is malamang sa malamang vertical forces only. Diba? Kung mag-summation of fx, kita nga da, waray man naton horizontal force on the general picture, on the kabugusan nga truss, waray man kata summation of fx, di ba? Summation of fx is equals to 0. Kasi we only have vertical force. So, our reaction would only be all vertical reactions. So, we have vertical reactions here and here. Okay? So, we call this R, A, R, B. Masyado atong ubos aton ink. Okay. Dire kasi ako artista. Joke lang. Okay. So, yun. So, again, we don't have vertical reaction at A kasi wala naman tayong vertical reaction on the whole truss. Okay? So, let us try to find RA first. Diba? So, one tip lang ha. Before you proceed on the analysis of truss, make sure that your reactions are all true. Kailangan permanente ini correct kasi pag magsayop ka mo nga all your stresses and every members is false. So, tanan ito sayop. Okay? Pag magsayop pala ka mo reaction. So, since duha man lang nga unknowns and this is non-concurrent, we can have 3 static equations. Diba? So, since we have 3 equations and we only have 2 unknowns, we can cross-check. Diba? So, let's try to find first our RARB. So using the summation of moment at point A that is equal to 0. So always assume, ako mas nakasanayan ko na talaga nga pag clockwise, positive. Para dire ka malipat. So summation at moment A, so RB is tipakadto. RB is tipakadto that is negative. RB, tama ba? Tama. RB times this training a distance that is 2.7 plus 4.8 plus 2.7. That is 10.2. Then we have this force, this 18 kilonewton times 2.7. That is opposite the direction of RB, so plus 18 times 2.7. This is equal to 0 since equilibrium kita. Okay? So RB is actually equal to 18 times 2.7 over 10.2. Which is equal to 4.765. So, I usually, pag sugad din nga mga forces, yan, para masara niya ako final answer, I usually round up to 3 decimal places. Labi na pag naka-kilonewton. But, kung kaya mo pa matigam ng tanan, pwede mo hiya ma-store to any letters on your calculator. Okay? Then, let's try to find, using another summation at moment B. So you might wonder, Mom, madali naman lang ito. Minus mo na lang 18 minus 4.765, di ba? Para makuha na natin RA. Well, anak ko niya kanina, it is better to double check. Okay? So again, RA, that is RA, that is clockwise, di ba? Times 10.2 minus 18 times 4.8 plus 2.7. That is 7.5. Nawawaran ako digo, so paano ko yan na? Real time. So our RA is equal to 18 times 7.5 over 10.2. That is 13. Sakto ba ito? Kinhini mo. Okay. That is 13.235 kilonewton. Okay, so then we double check. Using the summation of Fy is equals to 0. Again, we cannot use the summation of Fx kasi nga wala tayong horizontal. So this is the three equations I've been saying. Okay. So, we have RA is upward, of course, positive 13.235 plus 4.765 is equals to 18. Tama ba? So, 13.235 plus 4.765 is equals to 18. This is correct. So now, sure kita na ang aton reactions is correct. True na ang aton reactions. Sakto na ito, waray natin mababago. So we can now proceed to finding the stresses. So again, in analysis of joint method, so the method of joints, we start from the left joint, tika di middle part, then right joint, tika the middle part. So in this case, we'll start with joint A. Okay? Wait lang ha. Masyadong marami. Digipen. Okay. So let's start with the analysis of our truss using the chart method. Okay. Before I forgot, our length. Ay, joke. Itang ka rin eh. Para di kita may ngalimot, our theta is 53.13 degree and our length of AC is 4.5. So for okay. So let's start with at joint A. So I usually put at joint A. So, nga doon. Then, that is 53.13. quotient actual actually 3.13. Alright. So, ako lang. So, this is our action. Okay, so this is joint A, colorful. This is A. Medyo, no, bago pa kasi aton ballpen, asya daw pati. Okay. So, let us assume first the direction of our members. Wala pa lang pangalan. This is members A, C, and A, D. So, in assumption of directions of our members, that is either tension or compression. So, mano-mano lang na pag-assume. So, sa tingin niyo, ini kasi tikade, by the way, this is RA. So, if this is downward, so, ano tiya force nga ma-resist? So, just assume this as adit aton tension, ha? Our bottom chord is the tension. Then, our AC is the compression. Kung natisulo is compression, kung tigawas it is tension. Okay. Then, we have the angle. So, again, kung angle person kayo, can use the angle, pero kung mas prefer nimo on saw, an opposite of our hypotenuse, you can use this one. Sige, let's start with, so, again, since we are joint method, ang aton unknowns is AC and AD. So, this is two unknowns. However, di ba, we know that in a joint method, we can always find two unknowns. So, kaya. So, by one glance, makukuha natin. So, this is so, summation of F. So, hainit mas hay natin mas unahon. Fx, Fy. So, let's start first with Fy. Kasi natin Fy, may dagata given nga external, nga vertical force, that is RA, di ba? So, vertical force, adalat aton pag-isipan. So, pag mukha na ng RA, makakuha na kitahan AC. Tama? So, that is Fy is equals to 0. Okay. So, let's focus on this one, diba? Ade. Okay. So, RA that is negative. RA, we already have the value of RA. Pero adto. RA is 13.235 kilonewton. Then RB is 4.765 kilonewton. Okay. So, negative RA, that is downward kasi. Then, minus AC sine theta is equals to 0. Then, so we have our RA is, substitute lang ha, value is, I know, this is upward pala. This is plus upward, kaya pala. So this is positive. Okay. 13.235. Okay. 13.235 kilonewton minus AC sine 53.13 degree. Nayakan ako hypotenuse na kagamiton pero amalagap I came up with using the angle. Okay. So this is AC is equal to pera. 13.235 minus sine 53 sine alpha A equals to 0. It is also equal to 16.544 kilonewton. So let's try to use sine, that is 3.6 over 4.5. Same. So if you will use 3.6 over 4.5 in here, you will get the same answer. That is 16.54375. Yun lang, mas eksakto yung values niya. Okay. So let's move on to, so if you are to use 3.6 over 4.5, mas exact ano yung answer, which is equal to AC 16.54375 kilonewton. Di ba? Mas less siyang igsusulat. Okay. So we now have the value on AC, we now have the value on RA. So what is the value of our AD? So using summation of f of x equals to 0. Feeling ko di rin nakita. Okay ba? So summation of f of x equals to 0. So again, in this equation, we will disregard the vertical force, the RA, kasi vertical man yun, dito yung maihap. So, adinaliwat. Diba? Adalat aton kikitaon. So, in this one, we will get the horizontal component of AC. So, the horizontal component of AC is AC cosine theta or AC, in this time naman, I will using the hypotenuse. So, that is f of x is equal to 0. So, we have the horizontal component of AC. So, that is to the left. To the left, that is negative AC cosine theta plus AD equals to 0. Since we have the value of AC, ipalsak na natin na substitution. Then, we also have the value of theta. So, that is 16.544 cosine theta plus AD equals to 0. So our AD is equals to that is negative. Okay. Please carry on the sign always. It's negative. So this will be 9.9264 kilonewton. So our AC is compression. Our AD is tension. So let's try naman using so our cosine theta is equivalent to pera. Kung nga di 3.6 over 45, 4.5, nga di will be using 2.7 over this one. So note na diri iya ang 10.2 na gingamit ha. Kasi ang angle, kutob la nga diha 2.7. Klaro? Pero kung ini dako ini nga triangle nga da, kung hain niya ma-end nga di anta, unta, baka didi nga triangle. Mas nga da. So an angle niya is of course ini an iya adjacent, adi an iya hypotenuse. Klaro? Then adi naman an iya opposite. Anyways, that is in trigonometry. So our cosine theta is actually equal to 2.7 over 4.5. That is adjacent over hypotenuse. So try to find the value of using this one. So kung angle yung ginamit, panindigan mo angle nga tanan, kung hypotenuse ano yung ginamit, hypotenuse nga tanan. So para dire ka manipong, okay? So in this presentation, I just give you two possible ways in solving these stresses, okay? So this one, so if you're using the hypotenuse, our AD is 9.92625 kilonewton. So this is tension. So yun. So kung mapapansin niyo, this is almost the same, pero I would really prefer using the hypotenuse. Okay. Okay, so this one will be using again another angle. Then na naman, this is same, hadi good man. So this is theta. So this is actually, buta na lang alpha. So kung angle people ka, so might as well, panguha mo na lang ito tanan na angle. If we are to analyze the whole, the whole truss, okay? So let's proceed. So this is at joint A. Wait. So let us list down our values. So for member AC, that is equal to 16.544 kilonewton compression, and our AD equals to 9.92625 or 9926 tama, kilonewton tension. Okay? So, yun. High touch. Diba? Okay. So, ano pa tato next? So, next will joint C. Parang mas easier ang joint C. Kasi ito lula, given man na di. So, we already have AC. So, again, that is two unknowns. So, let's proceed at joint C. Rainbow naman kita. At joint C. Ay, no. Diba? Okay. Joint C. So at joint C, we have to draw again. Shit, makutihit joint. Kada joint drawing. I'm talking with my answer. Parang tanga lang kasi. Nakakatanga talaga ini na online, no? Oo. You really feel alone kasi wala naman nagko-comment. Abuti na era, master na siguro ni Nira. For a question, very good. Balik-balik liwat kasi ini. Okay. Bangin maya ka nila mo, masyado kami gini-elementary. Yes, sir. I guess. So, this is compression, ha? Kung bayin ka umalipat, since AC naton is compression. San aton kanina, di ba, nakapasugad. Nakapupula ko na lahat. Pasugad, di ba? That is compression. Pag makato ka iba nga joint, say this is joint C, ayun naman yung pasugad gihapon, that is magiging tension na ito. Compression is always tikad to hiya, ha? Pag nabula kasi ni ibang joints, nabalik na dito iyo, imo kabutangan. So, basta ang tigam na lang, compression is always tikada ha joints. Tikada ha joint at iya direction. Tisakob hiya pero no. Okay? So, may na kita AC, may na kita the force subjected to the truss at joint C. So, next is we need to find kita mag-assumption kita, mag-assume kita kung hain nga direction ang aton members CD and CE. Okay, so using your mahiwagang minds, hain kaya. So since tanan inihira kasi, puros na kita. This is downward. So kailangan may upward o din ang upward. So let's assume na lang this one as tension. Then tension. So anyways, if mag-save kita an assumption, negative man lang ito ya, meaning kailangan natin value ng aton assumption, aton direction. Okay. So this is, I think, easier kasi di ba puro sila ni horizontal, this is vertical. So pag summation of f of x naton, makuha naton diretso ang CE. Summation of f of y naton, makuha naton ang CD, tama? So let's proceed. Okay. Summation Marte. Dinaliwat. Summation of f of x is equals to 0. Nakikitaan. Sana nakikitaan. Okay. Then that is CE. It is to the right. Plus, I think, tayo pa natin assumption. CE plus AC. Ang natin cosine is, again, cosine natin is 2.7 times the over hypotenuse. So, if nalilipat ka mo, again, you can use the cosine theta. So, substitution na lang. So, that is negative. I think di rin nakikitaan. Di rin nakikitaan no, Sir Mark? Di rin talaga nakikitaan. Let's move this one. Yun. So, again, kung di rin i-bet, okay lang mag-cosine theta. CE, so that is negative. Oh. So this will be negative. So meaning sa'yo pa an assumption. Okay, so what is the value of CE? 16.544 times 2.7 over 4.5. So again, much better if you are doing the store technique in calculator. 26 kilonewton. So that is negative. So that is CE is equals to 9.926 kilonewton. This is tension. So dapat ngayon hiya ay compression. So summation of f of y equals to 0. That is function of f of y is damo na negative CD minus 18 plus AC AC sine theta or AC 3.6 over 4.5 is equals to 0. CD is equal to pera. Feeling ko negative gihapon. Minus 18. AC is 16.544. 3.6. 4.5. So, again, negative gihapon. Tama. All our assumptions are wrong. So this is CD is equals to 4.7648 kilonewton. So instead, niya tension, tanan yan hira compression. Okay. So it is very important na kailangan nimo i-indicate kung ano tiyo kabutang para diri ko malipat if you are going to the next joint. Okay? So since suppose na ito nga da. So our CE is 9.926 kilonewton compression. CD is 4.7648 kilonewton or 765 kilonewton compression. So let's proceed to the next joint. So as I said, from left to the middle to so since this is compression, let's proceed to letter D. At joint D, At joint D, we have this joint D. So joint D, we have a lot of forces, a lot of members. However, we only have two unknowns. Tama ba? Because we already have a value for AD and CD. Ang ato na lang kailangan is DE and DF. Okay. So, what is our AD? AD is tension. So, malamang pasugad. Again, away from the point, from the joint. Then, ang aton CD is compression. So, diba? Then, ang aton DE, so, we have to assume. So, since baka di na ini, so assume natin ini, di ka aton kailangan. Then, downward, kailangan natin upward. Diba? Para maging equilibrium niya. Diba? So, this is joint D. Okay, so, I have a question. Is theta equivalent to alpha? So, most probably that is no, because they have different value for the adjacent member, the 4.8, kasi ganyan 22.7 adi. Tapos they have the same opposite number. So, the angle alpha, kita pa ba? Alpha is equal to, again, kung angle person ka, you have to do this 3.6 over 4.8. That is alpha equal to 36.87. This is 27 degree. However, kung dire na i-zoom ko na eto. Delay ba ako? Delay, mas delay atak nahikitan. Parang nauna hi Mark. Uray pa nga ni ako na. Sang dinala. Anyways. So, if again, hypotenuse type ka, so you just have to find the hypotenuse of this one, the length of DE. That is square root of 4.8 squared plus 3.6 squared. Length of DE is equal to 6. So, again, mas prefer ko siya. Okay? 6 meter. So, let's find Midanakata. So, we have summation of ngadto kita nasa lang unknown, di ba? Summation of force, summation of f of x, usalatatan unknown, di ba? Kaya may nakita si D. We only have two vertical forces, two vertical stresses. So, ang aton DE, asyalaan may daan na vertical component ng DE and the member CD, asyalaan may ada vertical forces, di ba? So, these are unahon ta. Siyempre, unahon ta permanent yan, usalaan unknown. Para 0-0 dayon. Okay? So, CD. Our CD is downward, so that is negative. I always assume pag downward, negative, pag upward, positive, pag left, negative, pag right, positive. So, CD, then plus, DE is unknown. You can use sine alpha, or I will be using 3.6 over 6. Diba? Mas madali. So, our DE is equal to, ano ba yan? Naka-automatic. DE is equal to pera kaya. Our CD is 4.765. 4.765 plus alpha 3.6 over 6. That is 7.942 kilonewton. So, since we are correct with the assumption that is tension, then let's proceed with summation of f of x is equals to 0. F of x equals to 0. So, we only have a D, the horizontal component of DE and DF. Okay? So, let's start with negative AD plus DF plus DE. You can use cosine alpha, or in my case, I will be using 4.8 over 6 equals to 0. So, our DF is, our AD is 9.926. 9.926 plus DE use 7.942 I hope you are using your calculator in this discussion para maasabtan na yung nga direct na di binuwala pag solve, okay? So this is real-time solving, so I'm very sorry for the very fast solution. So DF is tension. Okay, so far may nakita nga diha aton left side. So let's now move on to the right side. So later on we'll know if we are correct or wrong aton mga members. As I said, we can double check this pag ada nakita ha. But nga. Okay? So green naman. So our DE is equal to 7.942 kilonewton tension. DF is equal to 3.572 kilonewton tension. Diba? Okay. So let's proceed at joint B. So matagal-tagal talaga. So at joint B, so again, so we have our B, then this is FB and EB. Remember EB. So again, with the assumption, since this is paigbaw, the only one yung vertical is a D na EB. So this is most likely paubos or na-compression. Then since pa right na iya, so pa left kita nga D. Diba? Ganun lang ang iya pag-assume. Okay? So this is again joint B. So our RB is 4.765. Tama. So EB. So let's proceed with summation F of Y. Since again, ang aton may value is RB. That is RB minus EB sine theta, or in my case, I will be using sine that is 3.6 and 4.8. Tama ba? Ay, 4.5. That is 4.5. Okay? So that is equal to 0. Our EB is equal to, so using the RB, 4.765 minus alpha 3.6 over 4.5 equal to 0. That is 5.95625 kilonewton. So this is compression. Then let's proceed to summation of f of x is equal to 0. F of x naman, this is simply as EB, FB is equals to EB cosine theta, or EB 2.7 over 4.5. Diba? So, pwede nila ito diretso na yung answer times 2.7 over 4.5. Matik na. This is FB is equals 3.574 kilonewton. This is tension. Kain ta na susurat. Kini kita pa man, ano, pwede pa ako mag-zoom out. So, zoom out kita para okay. So, EB is equal to 5.956 kilonewton compression, and FP is equals to 3.574 kilonewton tension. So let's proceed at joint. Find it much easier. Joint F first. At joint F. At joint F, easy lang ninyo. Joint F, we have FB. FB is tension. So again, parayo. Then, this is F. Then, we have FE. And we have FD. So, igbaw na lang ito. So, right now, we can actually check. Oh my gosh. Ayun. So, right now, we can check if what we did in the previous... I think right now, makikita na natin na naksinisiring pag mag-start ka diha middle, makita na natin kung check an natin ganyan mo, di ba? So, let's start with horizontal or summation of f of 9. Summation of f of x is equals to 0. So, summation of x equals to 0, we could conclude that fd is equal to fb. So, we have fd. fd is equal to df. Tama? So, since we already have the value of df, which is equal to 3.572, and we have the value of fb, which is equal to 3.574. This is approximately equal. So, 0.002 difference is not bad at all. That's why I'm saying na if you are going to solve something, you have to at least 3 or more decimal places para kahit pa paano ang iya difference is guti ay kaduro. Pero 0.001 o 0.002 discrepancy is 2 newtons pa ito. Medyo madako pa 2 newtons. Pero sige na lang. So, in terms of, so feeling ko, nagsayip lang kita natin mga pag-store. Okay? So we can say that we have a correct solution. So, with this given, with this analysis. So, at least kada paano, dire sayip natin bibinuhat. So, let's proceed with FE. So, aton FE, we could conclude that it is equal to 0. Tama? Because, waray man hiya other vertical forces at joint F alone. Diba? So, F is equals to 0. So, butang na lang kita, ha? An aton FB, okay na. FB and DF equals, so this is equal DF. Then, FE is equals to 0. Okay? So, ay nakita na joint. So, last joint. Hallelujah. So, I actually have one figure pa for Truss, pero wag na muna. So, let's proceed to the method of sections na lang after this last joint, okay? So, at joint E, we have So, ato na assume, pero that this is equal to 0. This is EF. So, EB is equal, EB is compression. Sorry. EB is equal to this compression, which is equal to, yun. Then, we have DE. 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 DE is tension. So, haros medyo nakatangatanan actually. Then, CE is compression. So, what we're going to do is just check the members that we have computed or check the stresses that we have computed, diba? Then, CE is compression. Okay. This is CE. This is DE. EF. Okay, based on this free body, so we can have summation of forces. What do you want to do first? This is alpha. Summation of F X. Anyways, pag-check naman ay So, aton summation of F of X, we have EB. EB and aton angle DD is theta. So, EB, we only want its horizontal component. So, EB, this is to the left, so negative. Horizontal component of EB is 2.7 over 4. We have CE. CE is a horizontal to the right. Then, we have DE. DE, so, diba, DE alpha. So, any opposite is also alpha. Please review that on your trigonometry. Okay? So, we need the horizontal component of DE. So, this is to the left minus DE times, again, the horizontal component is 4.8 over 6. Then, yun lang. 1, 2, 3. Tama. Is equal to 0. So, by substitution, can we have the value equal to 0? Let's see. EB is 5 points. So, we'll start with negative 5.956 times 2.7 over 4.5 plus CE is equal to 9.926 minus D is equals to 7.942 over 4.8 over 6, times by the way. So that is equal to negative 0.003. So we have, so approximately equal to 0. So most probably, ano yun na diferensyaan aton pag store and value. Okay? So, at least we are doing fine. So meaning we are correct in what we do, in what we're doing. So, the good thing ko yun na analysis of trust kasi bisan di rin na i-check hit ako ng instructor, hit ako ng work, makaya ka na ako nga correct ako. Kasi I cross-check, di ba? Maaram ka, at the end of the quiz, at the end of the assessment, maaram ka kung correct ka or wrong ka. So, this is very good. Actually, natalatak vetted statics. So, this is part of statics, pero in theory of structures, we'll be dealing with more crucial truss. So, ang EU statics is medyo basic truss lang, okay? So, So, yun lang. So, try to check paano sa summation of f of y. So, I think ang mga gawas gapon itong mga sugat din nga difference. Okay? So, yun lang. So, again, we use at the end of this joint, di ba? Nakatulo kita pag-check. Di ba? We check kanina at joint F, naka-check kita usa. Then, dinhi naka-check kita usa. Then, F of Y, maka-check pa kita usa. Kasi tanan na ini may values. So, what we're doing in this joint is just cross-checking, di ba? Yun lang. So, this is very good actually. Mao pa inihiyag homework, at least, maram ka mo kung correct ka mo or wrong. Okay? So, actually, I have another structure for this one, pero mukhang in just one structure na haros ako sa kauras. A very simple truss at that. So, I think, igo homework na lang ni nato na note. Yes, igo homework ni nato. So, let's move to the next method, which is much better. The method of section. So, ako talaga dira ko fan hini nga joint method kay kitaan naman guti-guti lang nga members. This is just 1 2 3 4 5 6 7 8 9 members pero pera na ako ka oras, pera na ako ka minutes. So, yun. So, let's move to the section. Section method. Diba? Method. Okay na. Sorry. Ano yung water break lang. Yes, sir. Para sa naglinis na kalugaringon, sir. Sige na katas. Anay, method of section pa lang. Balik ka, half pa lang ako tak discussion. Oh my gosh. Analysis of roof truss. Ayun na kita pag detailed ha. Oh my gosh. An? One three. Upod na shipping.
Ang iya pagpalit 1-3 na kung 2-1.
Pero sa Shopee, di na po sa Shopee, di naman po sa BBS.
Pwede man sir, kung kumangkat yung papalit ka na niyo, papalit ka.
Direct ka.
Ang kami na niya po, may nakasi niya laptop.
Pero kung if it doesn't work, kailangan mapapapagya po na laptop. Kung di rin mag-work, kung kumalit ako, sir, masabay ka.
Just in case waray.
Oh, just in case waray. Oo, masabay ako.
Sige.
O kumalit, may naman yung tip. Mas bara po.
Okay, the good thing in joint method of sections is if ever, sorry lang, I'm just writing the value of alpha.
Ay naman yun.
Sige na lang, sir. Kami na lang. Kami na lang, sir. Kami na lang. Thank you, sir.
Withdraw, ha?
Okay. So the good thing in method of section is that if ever your instructor want you to find the stresses of members CE, DE, and DF, di rin na kamo kailangan mag-joint method pa nga tutog. Di kang pa kamuha A, makali pa kamuha C, makali pa kamuha D, di ba? So, the good thing in section is you just have to make a cutting line or a section line between a truss members. So, number one rule in section method is you have to cut across 3 members. 3 members. Okay? So, this is 1, 2, 3 members. So, nga da kita pwede mag-cut.
Yun na, napasar ka na.
So, di ba? So, pwede ka kumuha, it's either left nga part or right nga part. Basta nga da ka mo mag-section. Nga da ka mo mag-cut. Diba? So, section A, ganon. Okay?
Ang backup plan ko, ang plan B, may subot di ako.
Masyadang mahugaw na ta ako.
Pero sige lang ang
Okay. So since we are using the same since we're using the same figure, so malamang sa malamang same letter RA ngan RB, okay? So let's start first with our section. Adit akong gusto ng section. So pili lang. It's either diha left or nga diha right. Okay? So ako mas bet ko ade nga right section. So again, naka real time kita. So pardon me for my slow decision making. So, oh my gosh. Ruler kita, gosh. So what we need to do is just copy the whole free body. Then okay. Okay. Ano ba yan? Okay, sorry. Nasusobrahan ka o cinema. Yun. So we have colores lang yan. We have joints B, F, E, yun. Then we have forces R sub B. So note na wala tayong external forces on this part ha. So except from the reaction RB. So shout out ang pinikapihon, okay? Then we have pala sa paka-member nga namawara. So please make sure na parehas talaga tiya ka-copy. Like ginkatla talaga naton. Okay? So then, also we have 3 members. Sasakto naton kakat. Okay? So what's our next? Next is, of course, we assume kung hain ni tension, hain ni compression, hain ni tension, hain ni compression. So again, in method subsection, we can find 3 unknowns. So in this case, 3 man na natin unknowns. So we can easily find this through our static equilibrium equation. Summation of f of x, summation of f of y, and summation of moment equals to 0. Okay? So let's assume first. So ato na yung assumption is tension, compression. Ay, this is BF. This is E. So gibutang ko la ini gibutang ko la ini for our reference later on. However, imagine na nga, wala ito nga da, aton hinipag assumption, okay? So, DE is tension. So, tika din na ini, maig-compression tanade. Okay? So, tig-igbaw kasi ini, so tiubos ta ini, kay para at least may ma-oppose, di ba? So, tension. Then, tika din na right, so tika din na ini, left. Okay, so adi, great na nala, tension. Okay, this is DE, and this is CE. DF. Okay, so what hain kita mauna pag, so if we are to use summation of moment is equals to 0, hain man kita mas preferable mag-moment. Again, mas preferable kita mag-moment kung hain damo it na intersect nga force. Kasi, once, di ba, pag mag-moment kita ito nga point, ito nga mga forces mawawara ito equation. Tama? Di ba? Kasi, mag-moment kahit nyo, wala man niya distance, ada man niya mismo iya point of intersection, di ba? So, wala iya moment. So, ang iya lamay the moment is, and may the moment distance or moment arm, which is df. So, much better kung mag-moment kita, nga diha, point E. Klaro ba't E? Okay. So, let's start. Summation moment E equals to 0. Again, clockwise positive. So, we only have two forces involved in summation at moment E. So, we have dF. Dira no klaro. Babawan ko na lang. Highlighter kasi inin na yellow. Okay. Summation at moment E is equals to 0. So, we have dF times, this is 3.6. This is same as this one. This is 3.6 meter. So, this is dF times, so clockwise, times 3.6 meter. Then, we have our reaction at point B. So, this is tika D. So, this is 2.7, by the way. So, again, just refer to the figure. So, RB, so our distance to point E is 2.7. RB is counterclockwise. 2.7 equals to 0. So, we have the value of RB. Of course, at the very beginning, permanente ko din yung natataon reaction. So, RB is given, so we can find the value of DF, which is DF is equal to RB times 2.7 over 3.6. When RB is equal to 4.765, that is equal to 3.57375 kilonewton. So, DF is tension. DF 3.0. We get the same value. Then, we have to find the value of CE, DE. CE and DE. So, using this, free body diagram, this the whole figure. Mukhang tama ba? Kaya pa ba? Okay. So, let's proceed with summation of forces horizontal. Yes, let's proceed with summation of forces horizontal. Pwede man gapon vertical, it doesn't matter actually. No. Mas prefer ko ang vertical kasi another for horizontal, we have two unknowns. We have DE and CE. We have the horizontal component of DE and the CE. This is horizontal. So, unlike at aton vertical, we only have one unknown, the vertical component of DE. Diba? So, let's proceed it again. Tag-usa let unknowns. Dimension of forces y is equals to 0. So, let's proceed. So, again, using this whole structure, whole body, this is our free body. So, inilat ako ng focusan. Ayun, kalimti na ang mga joints. Ini na nga bugos at focusan, okay? So, we have, so RB is positive. That is RB. Then, the only vertical force we have again is the DE sine alpha. Diba? So, but I will be using the hypotenuse. So, this is upward minus DE. Again, I'm using, okay, kuha, 0. So, DE is equals to, RB is 4.765 minus alpha x 3.6 over, sayang wala yan emulator. Okay. DE is equal to 7.9167 kilonewton tension. Oh, 9416. Okay. So, this is our DE. So, we only have the unknown CE. So, we can use now our summation of f of x is equals to 0. So, that is df, negative df plus CE minus DE. Again, cosine is 4.8 over 6 is equals to 0. We have CE is equals to negative df. df is 3.57375 plus alpha x minus DE is 7.94167 cosine alpha is equals to 0. And is equal to 9.9271 kilonewton compression. Okay, so when we compare the value of this one to our joint, compared to the process we've done earlier, the joint method. So, sige daw. Our DF is more or less same, di ba? Lalagay ko siya 0.00 something. Then we have DE, 7 point parehas. Then 9.9271. Yes. So, more or less, gato ilalagay diferensya. So, it depends on yung nalakan ang gamiton na process. So, yun. So, this is the section method. So, oray ka naman sa section niya daada nga iba. So, or less nga dila. So, may da mga problems nga damo ito nga dahabot nga pa, damo pat nga dahira ka series of triangle. So, you can use section method para at least in isang bagsakan la tulo ng unknowns. Unlike hand joints nga tagduha la. Diba? Okay, so, to analyze using the section method, actually, this truss could be analyzed using section plus joint methods para madagnit. Okay? So, kung ako ini nga di members din, na dinala, joint method ka na lang. Recommended an section plus joint. Oo. Oo. Oo, recommended talaga method of sections kasi nga 3 unknowns talaga iya kaya makuha. Kasi gamit pa yahin equation of moments or the summation of moments. Okay, so that is for analysis of truss. Actually, there are other methods like the methods of moments and shears and the graphical method. However, ang methods of moments of shear is parang analysis laya derived lahiya from series of computing da pang kung adlaw-adlaw ka na nagsisolve han imo truss nag-adlaw ka na nag-analyze, you can actually have a relationship between shear and moment. So yun, parang nakahimo adto naton mga banggiitan nga mga nag-analyze nakahimo rahin methods for using shears and moments. So if you want to know about that, you can have again look for Wang and Ekel book. Wang and Ekel is the author. The title is Elementary Theory of Structures. So ato dito ya. Then the graphical method. The graphical method is medyo crucial. At this point, medyo makurihiya ko. As I said earlier, it is a drawn to scale activity. So, medyo malipong ulo. Okay? So, it needs a lot of space compared to our algebraic method. Okay? So, that's it for analysis of trusses or the stress analysis of truss. So, let's proceed to ayoko na. Let's proceed to analysis of roof truss. Na water break. Sorry. Okay. So, in analysis of roof truss, so let me first introduce to you some parts of trusses. Roof truss, sorry. So, a roof truss, sugadini basically, siya na itsura. So, there are some unknown terms. So, unfamiliar is rafter, underpurlin or porlin. Underpurlin kasi adiya ubos, pero usually ada ito hiya igbaw. Ambot ano adiya ubos. Then, we have the ridge beam hiya, but actually ridge. May da kasi ito nga daan, ang pantaklob para diri magkuan ng tubig. Then, ayun pa ba? Ceiling joist, top plate, yun. So, this is basically the anitsurahan aton roof truss. So, inihiya ang typical roof truss kasi ano nga pansin niyo mga flat na aton roof. Or kung di man flat, so gapon hini pero gin tatahuban na nagamit na iran parapet. Okay. So, that is in 3D. So, din aton 2D. So, a roof truss, may daniya. Roof truss may daniya top chord. A roof truss is composed of top chord, may daniya purlins, may daniya. This is in 2D, kumbaga front view. So, may daniya wall plate, overhang. Actually, that mostly nga connection hit aton truss. Okay. Ano pa ba? So, in building design, we're in an open and obstructed space with a width of more than 40 or 50 feet to be provided. The roof is commonly supported by roof trusses spaced from about 15 to 25 feet apart. So, sugad ka haluag ang aton roof. So, these trusses may rest on columns or on masonry walls alongside the sides of the building. A roof truss attached to its supporting columns is commonly called a bent. So, the analysis of which will be treated on the next lectures. The discussion in the present chapter in this lecture will be limited to roof trusses supported on masonry walls. If the span of the roof truss is small, say less than 40 or 50 feet, the truss may usually be anchored to the wall at both ends, or the ankle bolts at one end may pass through slotted holes. in the bearing plate to make some provisions for expansion or contraction due to temperature changes. For longer spans, trusses should be hinged at one end and supported on rulers or rockers at the other end. Bagahin bridge. So I think you are familiar with this kind of supports, no? The rulers and the hinged on the rockers. So the bay, so this ay waray ka di kakikitaan. So the terms that we have to familiarize in this
Naka-okay pa din po. Susulat ka na.
level pa. Okay lang. Ano nakikita po ko an? Okay. So the things that we have, the terms that we have to familiarize first in analysis of roof truss is the following. Okay. So first, we have to, what is a bay? So a bay is actually the distance between the adjacent roof trusses. So an aton manggod talaga roof truss, an aton manggod roof truss is dili kasi nga dinagat na di nga configure. So usually may dito truss nga da, then at a certain distance may dito truss, then truss na liwat, then truss na liwat. So observe on your home right now kung may daan mga waray pa ceiling, an waray pa kesame, tapos ang nagamit roof truss or nagamit han truss, either wooden or steel. Usually so dito, truss, tapos another truss na liwat, then truss na liwat. Usually dito column, then sa nga column. So yun. So the distance from truss to truss is called a bay. The next term that you need to familiarize is purlins. So based on akon kanina mga ano ba ning akon? Sasarangit ink ta akon pen. Bago pala kasi. So dapat iyain. Okay? Purlins. Okay. So on purlins are longitudinal beams which rest on the top chord and preferably at the joints of the truss. So, an aton purlins, haakon nga di, adihiya under purlin, which is common nga mga trusses, adit hiya igbaw, or as you can see in this one, adiya baw-baw, di ba? An aton purlin. So, it lies above our top chord. This is our top chord, this is our bottom chord. This one. Nakikita ba? Okay. Next is span. So, ang span, kung gano'ng halabaan aton. So, the span of the roof truss is the horizontal distance between the supports. So, from here to here, that is our span. Ini yung kunhanan mga supports. Okay? Then, the right is the vertical distance from the ridge to the eaves. So, the right is the vertical distance from the ridge to the eaves. That is our rise. Or ini. Basta niya vertical distance. Then, of course, an run is the horizontal. Although the walls and the purlins assist in maintaining longitudinal stability, additional bracing is usually necessary. So, actually, pag sorry nga mga trusses, if para kita ka mo nga di inner court, way before, so, nostalgic moments anay. So, if parag observe kamuhan aton roof nga di aton inner court, di ba may nakamagtan na parang na X na balabag within hausa ka span and aton truss, that is mga bracings. Kailangan ito para kay though masusuportahan niya purlins, Pero diri maiwasan o diri man na kinahanglan laghapon naton bracings. Okay? Ano pa ba? So some uses top chord bracing or some others bottom chord bracing. So it depends sa paggamit. So trusses. So these are the common types of truss these are the common roof types. So you can read na lang its uses or kung paano niya gamiton again to the elementary theory of structures na book by Wang and Eckel. I think this is downloadable. Dira lang ako maaram kung diin, pero I think na-download din before ni Ma'am Rina. Okay? So, yun. So, these are the 8 common types of roof trusses. Okay. So, next that you need to know about analysis of roof trusses are the loads. Dead load, snow load, wind load. Panahon tanay din nga duwa. Snow load and wind load. Snow load is actually, though di-discuss lang natin yan for principle's sake, but in the Philippines, we don't have snow. So, technically, dire iniabuli kita aton discussion, hit aton actual analysis. Depende na lang kung magka-snow na nga ni Pilipinas, pero at least maaram ka mo how to. If ever may natumang ka mo abroad, at least you know the principles, di ba? Kung paano mag-solve paano mag-analyze in roof truss with snow load. Okay? Wind load is malamang as Philippines, bisitahin hit bagyo. We're in the Pacific Ring of Fire. Kanan volcano. Ang nagyapon, parang asya nagyapon, bisitahon lagi hapon kita. We're really vulnerable to wind, yun. To bagyos. Balito, yun. Bisan, actually, this past few days, parang I think may danat to bagyo, pero nakababatian ko, waray pangayan. Like, tiabot pa lang ng bagyo, no? Parang kuan pang lang niya, pala to, lower han bagyo. Diri pa tropical storm, di ba? Anya na, di ba? Imagine normal wind pala adto. Kumusta man? So yun. So we really have to know how to find this wind load. So and most importantly, we have the dead load. The dead load magkaduro di ano man. Always may ada dead loaded truss. So what are these? The composition of dead loads. So pamati na lang. The dead load includes the weight of roof covering. So, ang aton mga sheets, that is already a dead load. Tanan nga materials sa aton truss, naging kikarry ta aton truss, that is a dead load. Okay? Rafters, if any, and purlins is also a dead load. The weight of the bracing system, the weight of the truss itself, ceiling, and other suspended loads. Okay. So, these are our dead loads. So, tanan nga material na ginki-clear hit truss. If weight hit truss mismo, that is a dead load. Okay? So, and live load is, if ever may mga tao nga daw sigit lakat-lakat, that is a live load. Kamula, kung gusto niyo mag-dinaka't-lakat ayo roofing. Kasi ti roofing sugad ngayon, hini. It's up to you. So, ayun. Okay, so for analysis purposes, so we have only dead load, snow load, and wind load. Okay. So, unfortunately, in this discussion, we'll be using the English units kasi the formulas involved are empirical formulas using English units. So, dire kami pwede mag-translate into SI units, tapos ang aman gamit na formula is empirical English. When we say empirical English formula, these are parang readily available formula, parang na-derive na hiya before, pero na ka mga bagitan nga mga structural engineers, di ba? Gin-derive na nila nga mga formula, tapos at aton na lang pag-substitute. Okay. Okay, so for the dead load is, ang ginhatag lang nga empirical formula is for the wooden roof truss. So, ang kabug ato ng aton truss. Because other dead loads are given in pound per foot. So, usually, have problems with the niton hatag. So, for wooden roof truss, we have HS Jacobi formula that is W is equals to 0.5 plus 0.075 L. For steel roof truss, we have CE Fowler. I think I have to write this one. Sorry. Di na. Kapaparong ko na. Lagi ka, di masarayo pa.
Pero, buti delay na daw.
Madahanim gutilat delay. Kay haros nagkukuan ka na, kakaliak ka kasi na. Oon. Hindi ako, dako-dakot delay. Okay naman. Okay. So, we have these empirical formulas for the... Oo. Sorry. Chika na kami nga di. Sorry. Okay, we have... This is for the weight of truss. Cursor, makisama please. So, W is equal to 0.5 plus 0.075 L. Where L is the span in feet. O, diba? Kita niyo, naka-English talaga siya. So, dire kami pwede maggamit SI units. So, this is for wooden roof truss. Then, we have 0.4 plus 0.04 L. This is for steel truss. Ay, oo. May dako ngayon kuan. Sorry. Okay. Steel trusses. So, this is by HS Jacobi and this is by CE Fowler. So, again, L latatan kinahanglan dili ha. Our L is in feet. The span of your roof in feet. So, we have the snow load is usually 8 pound per, maybe taken at 8 pound per cubic foot, and that of wet snow at 12 pound per cubic foot. Again, the dry snow may be taken at 8 pound per cubic foot, and that wet snow at 10 pound per cubic foot. Usually given ito problems. By the way, the W in here is weight of the truss in pounds per square foot. So, naka-pounds per square foot ito ya. Pag in kaso, diri inighatag, so you have to solve this one using this formula. Okay? Then, we have the wind load. The wind load will be using the Dutch-Siemens formula. Actually, we have this, the wind load as recommended by the 1940 ASCE. So, again, medyo, kuan naman ito yan, 1940 pa. So, we have, actually, may na nakita, di ba yan, INSCP 2015? For the Philippines, ito niya alone. So, for the purposes of explanation lang right now, we'll be using the Dutch-Siemens formula. Okay? So, the Dutch-Siemens, di na naman rin higahatag problem, ha? Memoryahin niya. One plus sine squared theta. Where Pn is the wind pressure normal to an inclined roof surface. So, P normal or pressure normal, wind pressure normal, and your P is actually pressure. Your P is the wind pressure in pounds per square foot of vertical surface. Wind pressure. Ano ba yun? Wind pressure in pounds per square foot of vertical forces. Yun, vertical surface ya. So, ato niya gin-solve ya into, kumbaga siya ni, di ba? Side view kita ha. Nakikitaan ba? Nakikitaan ba ito, Sir Mark? Ito nga.
Kasi pag mag-drawing ko nga yung mga malaking kuan, balay.
Oo, lagi nakakuan man hiya. Nakasugad. Oo, di ba nakasugad hiya. It aton kasi, usually kasi nga given is pasugad. Di ba? Vertical. Vertical, tama? However, ang aton manggod liwat roof. Aton manggod roof na, ano pa? Okay. Ano ba ito? Vertical surface. Ano aton manggod roof kay pasugad. So, dapat pasugad at aton kung kanon tiya wind. Nasugad man ang wind. Oo. Dapat na, aton target is hatras. Hatras, magiging normal hiya. Mga sugad. Diba? Ganun. Normal hatras. Amo na. Normal hiya. So, dapat ini is, normal ha roof. Normal ha roof. Anyways, kung ano itsura hatras, asya man gapit itsura roof. I mean, kung ano ka-incline ito yung matras, asya man ka-incline ito aton roof. Okay? Masyado ako delayed. Okay, so yun. So, this is, makakayakan ka lang normal if this is perpendicular, diba? Ini aniya inclined, tapos anin mo kuan, anin mo load, that is normal. The theta, this one. sorry. Oh my gosh, delikado. Our theta is our theta is the kuan actually. Kung ano an inclined niya from the horizontal. An roof, hala, joke. Doon akong cursor. No ba yan? Naton theta is adding. The usual lang at theta. Pagbungkat akong truss, hiwi-hiwian. So, yun lang yun. So, this is, ano yung theta, ano aton vertical, adi, ano aton horizontal. Horizontal, adi. Yun lang. The inclination from the horizontal. Okay. So, this is joke. Inclination from horizontal. Okay. So, yun. So, ano pa kinahanglan? May nakita wind, may nakita snow, may nakita dead. So, let's try to have an example. Ay, by the way, so let us explain na lang it later on. Wala, mag-alas 5 na. Ang bilis lang naman. Okay. So, one last example. So, example, based on normal working stress for vertical loading, determine the maximum and minimum stress and all members of the roof truss shown. This is a hoe truss, I think. And this is a hoe truss. Okay, hoe truss. So, yun. Supported by beams. Then, the data for the analysis are, so, on bay length given, this is 15 feet. So, on bay length, there natin yung makikita na front view, ha? Kasi that is the distance from one truss to another truss. Then, the span is 36 feet. So, this is the span, 36 feet. The rise is 12 feet. So, given man nga ni. Then, The dead load consists of, so the undead load, this is already given. So, might as well, tigaman na lang ang mga da. Then, we have the Dutchman formula. So, ginhatag ang Dutchman formula kung mga swerte. So, ang snow load aadi, wind load is aadi. Then, so the snow load is given in the roof surface. So, take note that the weight of roofing, rafters, and purlins is given an iya pound per square foot in roof surface. Then, an iya weight of bracing system, roof surface. Then, ang truss is horizontal surface. Then, ang ceiling is horizontal surface. So that when you have the Dutchman formula, so given, the truss is anchored at both ends. Wind reactions to be assumed parallel. 33 and 1/3% increase in working stress allowed when wind effect is included. So we have the load combinations. By the way, load combinations, self-explanatory. So, dead load plus no. Load combination na ito. Dead load plus wind. Load combination na ito. Ganun lang. So, yun. So, let's try to find. So, ulit atong gusto ipakita para mas kung how to solve that one. Okay. So, din aton ha given. So, ang aton bay daw is okay, naiihi na. Actually. Can I have a break first? Wait lang.
Ha? 12:30 na, di na lang kumupalit. Bulit na ito. Balay.
Alright, welcome back. So, yun. Basbasan ko nini, kaya hindi rin ako nalot makauli. So, right now, ang ako nalahin i-discuss is how to get the wind load, the dead load first, the snow load, and the wind load. So, di ba, ang aton yung pinapabiling natin as unload combinations, then ipapa-analyze ang aton truss. So, let's put the truss first. Truss example. Ayan, tama. So, adin aton roof truss. Okay. So, this is our roof truss. So, ang pag-analyze, hinis, again, ipa-find natin ang stress per members. So, that is for you to find out. So, we have first to find our dead load. So, di ba, ang ginaaro din niya is combinations. So, to make it easier, we have to tabulate it. So, ang dead load anide, then snow load, then wind load. So, let's start first with our dead load. So, how to find the dead load? So, our dead load, in our dead load, we have, so let's first find the length AB. So, in this one. So, in the analysis of the roof truss, so by panel kita. May panel kita ha. So, in this member, adan AB tikad to. BC tikad to, CB tikad to. Pero, since ang aton load is kimubutang man ha A, so, this is half DD, then B half DD sa nagiging whole, C half nagiging whole, then D is half whole, then so on and so forth. Okay? So, let's first get our dead load. Ano po? So, for dead load, so let's find first the length. Kaano kailangan natin ang aton length AB? Because may ada kita mga given na roof length. So, natin roof length is ini nga AB. Length of AB. This is actually equal to, this is 12. 12 divided by 3, that is 4. Then, the horizontal distance is 6. So, that is 4 squared plus 6 squared, or equal to 7.21 feet. So, next is the tributary area of roof surface per panel. A roof surface per panel. Na automatic kasi. So, how do we find the tributary area of roof surface per panel? So, we just multiply the bay. So, an aton tributary area is an aton length, kumbaga inihiya nga length, times an iya distance, di ba? Tikadtuhan iya other truss. So, that is the tributary area. Parang nararectangular iya, pero sa ganito. Dito kasi bako kasi mag 3D, ano ba yan? Anyway, so kung nag-3D kita tipos dito, that's good. Ini nga area. Okay? So that is 7.21 times 15. That is in the roof surface, ha? So that is bay times the length of AB. So our bay length is 15 times 7.21, that is equal to 108.2 square feet. How about our tributary area of horizontal surface per panel? So, since per panel man hiya, and the word horizontal surface, ang atong kailangan lang is ini nga horizontal. So, that is bay again, times the horizontal distance. 1 or 90 square feet. Okay. Okay, so let us now find the panel load on top chord. So, in finding the, so for the dead load, kailangan natin i-find ang aton mga forces. So, kung mapapansin niyo, na truss, waray pa talaga hiya load because, so, hain ka ba naman makakita yung analysis nga ada na tanan. Like, ang kalat na nakakita actually quiz exams. But in actual life, you have to find based on the given material, tanan, imo talaga tigpa-find. So, pag nag-analyze ka na, engineer ka na, dire mo na ito, may kitan, uy, may load na, given na, so kanita load. No. You have to find the load on yourself. Paano mo i-analyze na maging load here? So, this is how, di ba? So, we are teaching you the principle on how to analyze, di ba? Any raw data, hindi kung tutuusin, though given lang somehow, ano ba nga data? Okay? So, may ada kita. So, natin bibilangan is ang load niya per panel. Per panel, so meaning ang area ni times di daha. Okay? So, panel load. Panel load on top chord. Again, top chord. So, panel load on top chord. Ano ang mga materials nga ginkakaptan na atong top chord? Ano? Ano? Ang materials ginkakaptan na atong top chord are the weight of roofing, rafters, and purlins. And we also have the bracing system and the weight of the truss. So, for this example, an aton bracing and weight of the truss, butang naton han top chord. Okay? So, giga-assume hiya naton nga ang nakapot han aton bracing, pati ang weight of the truss itself is the top chord. So, pwede, ang iba, some designers, they prefer nga half-half. Half han load, han bracing, kakadiha ha bottom chord. The other is kakadiha top chord. So, bali half-half. Both for the weight of the truss and weight han bracing systems. But, for the purlins, rafters, automatic nito yung top chord. Okay? So, an aton purlins, raftings, roofing, tanan man itira. So, usually, ang nakapot talaga ito niya is top chord. Paulit-ulit na ako. So, that is 16, di ba? 16 feet per square foot, di ba? O pound per square foot, yeah. So, plus 1. Plus 1 kasi ang bracing system times 108.2. Gin-multiply natin hiya because ang aton 16 or the rafters or the roofing, rafters and purlins naka roof surface. Then gin plus 1 na lang naton kay same and bracing system naka roof surface. Then gin-multiply natin by the roof surface 108.2. Okay? Then also an aton weight of truss. Weight and truss is naka-horizontal surface, so that is 3.2. Again, if this is not given, ini nga 3.2, you have to use the empirical formula. So, pag diri ni ginhatag, malamang hatag kung wooden or steel. Okay? So, that is 3.2 pound times the area for the horizontal surface, that is 90. Okay? So, which is equal to 2,130 pound. Then, for the panel load in bottom chord. Amo na. Bottom ba? Tama. Bottom, ilarom. That is given man, 10 times 90. Ano? Ano? That is weight of ceiling. Weight of ceiling, di rin na nato di ka top chord. Kay kung familiar ka mo ceiling, ceiling is kisame. Kumbaga, in this problem, it involves kahit paano imagination, di ba? So, you have to know, you have to be familiarized at mga materials at mga structure. So, that is 9,000. Ano ba? Oh, 900. Ano ba yan? Sobra. Pound. So, you already have the loads. Ang pakiana, paano ito naton ibubutang? To 130. Plus 900. Ano daw? Teka lang ha. Amo na, ada na. Oh, joke. Okay. So, paano? Inihiya is the load. So, inihiya, naka in terms of pound, naka in terms of per feet squared. Tama? Per feet squared. Naka aton horizontal, aton panel area. Di ba naton roof surface is pasugad, di ba? So, how should we put this? So, again, hadi kanina nga B, A, di ba? Half this one, half this one. So, whole. So, ini nga wala ni problem. B, C, D, E, F. So, that is, pero ini. Igpulataan top chord. So, this is, then downward. Dead load, normal na ito. So, that is 2130 pound. This one is again 2130 pound. Then 2130 pound. Then we have 2130 pound. Then 21. Oh, ano ba rin na ink? Ano ba ini? 21. Malabad. Anyway, so, yun. 2130 pound. Nakakaloka. Okay. So, di ba ini whole? Ini half, di ba? Whole na hiya. How about A? Di ba? At aton talaga assumption, aton pagbutang hinload is within the joints or ato talaga joints. So, at aton, aton area is this one la, di ba? Tas tikad to. So, half of area. So, half the lot area pound. So, that is 2130 divided by 2 is 1065. 1065. 1065. Okay, let's move naman han aton bottom. Same, ini nga area naton bottom chord, ini nga area, asya naton panel, ini nga area panel. So, again, at this one, 900 kompleto. This one, 900. This one, 900. Pound ito ha. More na space. 900. This one, again, is 900. And this is, oh, joke. Kato nga hiya. Na-taken, That is 450. And this one, this is 450. Okay? So, inihiya, ini is just the same joints. Paras downward, so we can add. Para diri ka magdinamo. So, we can add this one. 450 plus 1065 is, kano ako rin mag-change in color? 1015. Tama? 450 plus 1065 is 1515. Sorry. 1515. 1515. Sorry. Pero nagbawas. 1515. Delay ka, Joy. Nag-change na. Okay. This is 1515. Okay, so now you already have the load. So, same with what we've done kanina, nato analysis of trusses, you proceed to find the stresses in the members. So, of course, ma-start ka natin reactions, then, ang mga members na, ang mga stresses natin na members, okay? So, that is for the dead load. So, let's move on for the snow load. So once you finish the analysis of this truss, you tabulate this one. Yan na lahat, yatsura. So, yan na lang. So, let's proceed with the susunod. With snow load. So, on dead load, actually, medyo makotean pagkuhahan iya load. Okay. So, snow load. For snow load, madali linin. For snow load, given na an iya 10 pound per square foot of roof surface. So, again, roof surface. So, ano natin snow load? Panel. Ang snow load, so, snow load, hain na kita magbubutang hin loads. Should we put the load on the top chord or the bottom chord? Sige daw. Top snow load. Okay, top chord. Very good, Sir Mark. Like, ano na ini? Wait. Hindi rin kinikita. Feeling ko. Okay. Compare tala later on. Okay. So, for snow load, so we have the panel load for the top chord. Again, wari na kita nga diha bottom chord. Kaya wari man niya weight na gikakapta ng snow load. Unless na labuhot iyo nga da load yan may nga to na hiya ha ceiling. Abuhot iyo nga da roof nga nga din na ceiling. So, malamang an iyo snow load, di na ayo bottom chord. But I bet you don't want that to happen. Sige. So, for snow load, we have panel load on top chord. Ato na lagod. Bottom chord na. So, that is given here, 10 pounds per square feet. Horizontal surface. So, oh no. Roof surface, aniya ginhatag nga area nga weightan aton snow. So, times 108.2. So, that is equal to 1080 pound. So, diretsyon tanaan aton wind gihapon. Wind load using the Dutchman formula. Pn is equals to P times 2 sine theta 1 plus sine squared theta. Wala memorize ko na. Okay. So, our theta is this one. So, this is arctan 12 over 6 times 3, 18. Diba? Pero makahubya. So, ako nalahim, ko nala natin sin theta. Sin theta is equal to, ayan. Okay. 2 over square root of 13. Bala ka mo kung ganun ito niyo pagkita. Or that is the, that is derived using trigonometry. Okay. So, our P is given. Kanina, ang problem, P is 30 pound per square feet. Pressure, 30 pound per square foot in vertical surface. So, that is what we really need, the vertical surface term. Okay. So, dapat naka-vertical surface siya. So that is 30 to ini kung paano ni na-derive. Kailangan ko pa ba specify kung paano na-derive? Sige na daw wala. Bayan ko muna lot magpakiana ha chat box. Okay. Sa theta, di ba, unusual ang mga angle person, madali la over 36 feet. So, you can have the answer. Ako, kay mahilig ko na ako shortcut. Gusto ko, sin theta is equals to 212 square root of, joke, di rin ako magamit sin 12. Gusto ko na Gusto ko adila. 1, 2, 3, this is 4. 4 square root of 4 squared plus 6 squared. So that is square root of 4 squared plus 6 squared is 2 square root of 13. So that is 4, 2 square root of 13. So cancel a day. We have 2 over square root of 13. So that is our sin theta. So 2 square root of 13. Okay? So, of course, ang mahilighan theta, pwede ka mo gumamit ng arctangent. Same lang kagagawsan. So, asan ka na? Okay. Then, 1 plus 2 square root of 13 squared. Oh? Squared. Which is equal to 25.45 pound per square foot. This is still in roof surface, ha? So, baga, naka-roof surface pa hiya, o pound per square foot, but we're looking for pound na lang. So, we have to multiply this one to 108.2. Naka-roof surface naman hiya. Okay? So, our panel load is 25.45 times 108.2, which is equal to 2,750 pound. Okay, so now we have the panel load. So let's ibutang na nato nini nga mga load sa ato truss. So we have in this one is dead load. So didi kita snow load, that is the wind load. So snow load, i-blow kita. A snow load, same. This is 1080. 1080. Same. 1080. 1080. 1080. Then, we proceed with, so 1080 divided by 2 is 540. Yun lang. Pounds in tanan. So again, panel load on top chord. So waray na kita ha bottom chord. So you proceed to finding the reaction, then find the source on each member. So may daka na ito ay tabulate. So, yun. Then, proceed na kita nga diha wind load. So marang kita ang aton wind load is 2,750 pound. Ayaw nga matanggal. Wow. Special siya. Okay. So, wind load. Ha wind load, diri hiya parehas hadi nga mga vertical loads la. Ha wind load, that is normal. Diba? Pn, mga na natin ginkuha. So, that is P normal. So, that is perpendicular to our roof. Okay? So, anaton Pn is, so, again, anaton area nga di That is 2,750. 2,750 into 750. And, by the way, an aton wind load and condition is either left or right. So, adil natin din consider nga left. So, usala iton. Siyempre, kung ato, imagine ako iti mo roof, di ba? Sugad. At iti mo hangin, paloyo-loyo, ambot na lang ako kung natuklap na iton. Okay, so, siyempre, pag adit usa, wala nga adit usa. Leeward adi nga usa. Okay. High nad to. Then, so, ini nga area. Then, this one is half up to 750, which is 1,375. This one also is 1,375. Okay, so you find, so, again, we consider, kasi an aton situation is wind load either side. So, nagpili lang kita. So, naton is left side. So, ikaw na laan, kamuan ma-proceed for the analysis of trusses. Okay? So, for your convenience, I have to give you the values. Pwede ba? Pwede ka ma-share? Wala ako picture. Han values, aniya na members, aniya na stresses. Oray ko nga ni picture. Hindi ko nalaging picture, tapos para masya-share tayo ni agad-agad. Ay, oo, di na masya-share online. So, ayun. So, after you, so actually, ang problem hini, ayun na lada. Oh, ako ko na lang na workplace.
Use one na lang. Google Keep.
Oo, Google Keeps. So, parang ganon. So after you tabulate, you should tabulate kasi talaga, kaya para dire kang makorean. Kasi ang yung bibiling hindi ba is the three conditions, the load combinations, dead load plus full snow on both sides, then dead plus wind from either side, and dead plus half snow on both sides plus wind from either side. However, based from our analysis, an aton lang maximum, an aton load, wind load is, kung magko-combination kita, dapat andiri hiya na dako, paano ba? An aton combination 100 plus snow is greater than the 3/4 of our dead plus combination of other loads with the wind load. So, siya condition. So, ganun. Siya ba? Wait lang. Let me recall. Okay lang. O, see? Siya ito. So, Norton combination to dead plus wind on either side. Okay. So, magiging maximum, ang bibilihin actually ng problem is the maximum stresses. So, you have to tabulate. So, ano yung pag-tabulate? Hatag ko na lahat yun, form. Wait. So, ano yung pag-tabulate? Oh, joke. So, ganda lang. So, this is the members. Stresses na yun ya. Dapat naka-stresses na ya. Dire na laya loads. And stress good talaga ya. So, naka-specify ya kung negative for compression, positive for tension. So, garon tanat aton signing. So, negative compression. Joke. Positive tension. So, karon na lang. So, that means dire nagmamatter ko negative or positive. Maximum lagapan ito na. So, ang gibibilang din is maximum stress. So, din is for dead load. Din is for snow load. Din is for wind load. So, either left or wind right. Then, we have the combination dead plus snow. Then, ang second condition is dead load plus half of snow plus either WL or WR. Diba? Then, the third condition is, adi pa nga yan, dead plus wind left or wind right. Then, ang iyo himuon is, we have also, yan na letter for special. Then, this is the maximum load. So, according to rules, according to conditions, bali nayakan heya. So, if load combinations dead load plus wind load is selected until damo pa with mga ice pa to combination actually, is selected, will not be controlling unless the resulting combined stress exceeds 4/3 times that times hadinga D plus S. So, if your D plus hini naging 4/3 maging 4/3 times D plus S, meaning adit yung maximum load. Kuha. However, okay. So, pag adi mag-exceeds. Pero kung hindi mag-exceeds, you have to have this one. So any combinations with the wind. Ay, shucks. Oh, ngayon. Sorry.
Diri, ayun na. Diri, gusto diri na ipadinalan din eh. Tapos, ipaano din na.
Oh, sorry. Diri naman na nang kinahanglan. Okay, sorry. Yun. Diri kinikita. Okay. So, adi, di ba? So, an aton condition is, so, ini, pag, unahan to. So, D plus wind. So, any combination with dead plus wind and wind out, dead plus ice. Ano pa itong combinations? Basta may the wind na combination, kailangan 4/3 times hiya kumparahan aton D plus S. Tapos, pag diri ka mag-suffice itong condition, so we have to move this 3/4, we have to have the value of 3/4 times D plus adi nga combination. D plus S over 2 plus wind. Wind load, tama? S and S. So, pag ang D plus S dako kumparaha din, then ang makontrol han aton design, ang aton gamiton nga design is our D plus S. But there are some members gaan mas maximum niya is adi nga 3/4 D plus S. So, aton nala daw butang nga kung ano ang aton mga maximum. That is depending on members. So, kung anon mga maximum stress, asya ton gagamitan na aton design. Okay? So, after which, pag makuha na kung maximum stress, you can get the maximum allowable size na, diba? Sir Mark? Hello? Anyway, so, after which, in real life, kung makakuha na kamo in stress, usa ka member, makakakuha na kamo kung piraan iya allowable size han iyo trust member. Yun. Okay na. So, asya to pag-design. So, this is parang tikad to nakitahan aton real task as an engineer. Okay? So, this is an application basically. So, that is how Mauricio theory is. Okay? So, that's it for today. So, any clarification would be entertained in our workplace chat. Okay? So, for your nag-practice exercise ba kita yan ate?
Sir Mark,
Nag-practice exercise ka? Nag-practice exercise ka?
May daw.
Okay, so I will give the practice exercise later na lang pag uli ko. Actually, may dako nga di excess nga. Wari ko di ba kanina makag-example ang usa nga Truss. But I will kakano ni mo deadline?
Saturday? Friday.
Sige, next week akong deadline. Dadagdagan ko yung process para na-practice ka mo. Kaya di rin na in statics. This is already theory. So, you have to have a lot of practice. So, we're very sorry nga natigda ang iyo tasks and napahalaban iyo hayahay moments. So do we. So, this is, kumbaga, ano yung gigukulbaan, hayahay ka mo for how many weeks. So, this is it. So, it's payback time. Joke lang. Wag naman, wag naman yung seryosohin masyado, no? This is for you to learn. This is for you to practice. This is for you to be able to, like, kaya ko naman ngayon. Masayan man lang ngayon. Diba? So, ganito. Diba? Like, paulit-ulit naman lainin. Diba? So, God. Diba? Oh, this is not dire man ni duro-duro nga pressure. Ay lawat ka mo ba kay stress atong topic ag pa stress liwat ka mo. So let the trust handle the stress. Ayaw ikaw. Okay? So this is it. So with this table maybe sir ato kan sir mark on picture so he can share the result. So you can adi yan yung picture ang results kasi ato niya stress. Or mga picture. Sige nala, ako nala na mag-share. Pero, syempre, with Diryodo. Taganta daw ito ng libre nga load nga mga tao. may pa-loyalty award. We really have to make really have to give them practice exercise kay so dito nga 8 people na lang, di ba? Kailangan talaga nila mag-aram. Kasi di rely ni ano.
Maybe we can give them kuan madam. Sample problem ini nga kuan may that table.
Amo lagi mga taga kon sample problem. Kasi negatag ko an answer para may danira problem. So that's it for today. Bye. Ciao. God bless everyone.